Hello everyone. Today we are going to discuss the speed control of the DC motor. Okay. So here introduction. So one speed control device. So even conduct the shunt and series motors. So we are discuss about the topic shunt and series motor speed control methods. So speed control and industrial drives necessary to achieve the product. So here necessity of the speed control. So మనకు necessity. So speed control DC motor చేయాల్సిన requirement. So first we'll talk about the speed control definition. So intentional variation of speed according to the requirement. So intentional variation of speed according to the requirement is called the speed control. So mechanical. So we can learn that is the speed control by means of the mechanically. So it is speed is varied by using step put pulleys. So here we are having gearing systems, right? So set of gears are placed, right? So from that we do the mechanical speed. Okay. So from that one we do the setup changes. Next, so electrical. So if coming to the electrical, speed control motor having the greater advantages over the mechanical side. So in case of electrical speed control, so they're having some advantages by comparing to the mechanical, because his mechanical we need set of gear system. So but in case of electrical we required the restart controlling or speed controlling techniques, that is by means of voltage current variations. Okay, that's meaning the some more advantages. So the DC motors offer the easy speed control. So in speed, DC motors are widely preferred. So comparing to AC, so we are having some more advantages in speed control is DC. In DC, that's why we are going for the widely for the DC motors. So necessity of speed control. So here necessity, so we'll talk about. So DC motor often fine speed control hence so strong competition in modern industrial application. So speed control the very fine speed control comparing to the AC. That's where we are going for the strong competition in modern industrial applications. So possible time speed control we talk about. So here, so how we are controlling the speed. So by means of the here we can write so back EMS. So back EMF we can write as N directly proportional to EB and indirectly proportional to the phi. So by means of the here we can by controlling the back EMF and phi, that is flux through the field. Okay, so we can control the speed of the DC motor. Okay, so we can take the here from EB. Okay, so that is the voltage input. Okay, supply voltage input and armature resistance. Okay, so that is a we can write the N is directly equals to EB by 5. Okay, so that means supply voltage. Okay, supply voltage is controlled. Okay, then is the speed of the motor also we can control. Okay, so here speed can be changed by varying the supply voltage, resistance of the armature, and flux per pole. Okay, so the armature resistance we can control so by means of the back EMF, and supply voltage by means of supply voltage to the motor and flux per pole, that is a magnetic field. So that will be controlled by controlling the exciting current through the field. So the methods of speed control will have in the, so first we'll have the by means that voltage control method by means of supply voltage, and armature control method, that means armature across. Okay, so by means voltage across armature, and field control, that is the flux per pole is done by the field control method. So these are the three methods of the speed control. So here, if you talk about the DC shunt motor speed control, so DC shunt motor is widely used in many applications in such that, so that is a centrifugal pumps, reciprocating pumps, fans and blowers, lathe machines, mission tools, and wood. Okay, sorry, this is the mission tools. Okay, so another we have the woodwork. So in all this we are using the DC shunt motors requiring the speed control. Okay, centrifugal pumps, reciprocating fan, fans, blowers, lathe machines, mission tools. So all are in different speeds. So for that we need the different speed control devices. Okay, so here flux control method. So in the flux control method we are using the here in this that. Okay, let's talk about here the flux. That means the excitation. So excitation to that. Okay, the in DC motor, so we are controlling this flux. Okay, so in the flux control method we are controlling the, so we are having the speed, that is eb is directly proportional eb, and speed is inversely proportional to the flux. So if the flux is decreases, the speed is increases. So here for controlling the flux, so if the flux is going to the in the field winding, right? So field winding induces the magnetic field. So if you control the magnetic field, so in terms of the current, right? So that current will be controlled by using the rheostat. Okay, so here we are using these variable rheostat. So whenever we are controlling variable rheostat, okay, so magnitude of the current will be decreases, that is flux, if it is decreases, the speed will be increasing. So if we observe the graph between the speed and field current, so here higher field current. Okay, so here we are hoping, so if it is decreasing the speed, okay, so if sorry if you decreasing the field current, you are increasing the current. Okay, so higher if, so lower speed. If you are decreasing the field current in these, so the field will be increasing. Okay, speed will be decreasing. So that's why practically we are getting the like this. Okay, so in the principle we're getting that the based on equation, okay, n directly proportional to n indirectly proportional to flux. So higher the flux, lower will be speed. Okay, so lower the flux, higher speed will be get. When speeds can be varied by changing the flux. So construction if we take, so a variable resistor placed in the series with the shunt field winding. So shunt field resistor reduce the shunt field current and hence is the field. Okay, shunt field rheostat reduce the shunt field current. Okay, so when you connect this rheostat, okay, here this shunt field, this flux. Okay, so here what we are done, the shunt field current is there. If you control this, so the speed also you can control. So reduction in field flux increase the speed of the motor. So flux is less, the speed will be high. Okay, speeds above the rated we can obtain from this method. So from that we getting the higher speed. Okay, so double the speed of the rated value is achieved. Okay, that's why we are getting the higher speeds. So he easy and convenient method of speed. So that is one of the advantages in the speed control method. And inexpensive method since very little power is used, because here the field current which you will having, that will be very less. Okay, so that's why getting the inexpensive method. So independent of load on the machine. So whatever the load is there, okay, does not affect that. So that's why it is independent of the load on the machine. Okay, so disadvantage is that we talk about the disadvantage of the field control method. Higher the higher than the normal values of speed can be obtained. So this will have many major cause, and wider speed ranges there for this the instability and pure commute. So if you are going for the higher speeds, what will get at the commutator will get the pure commutation will be take place because of the speed ranges. Okay, and there is a limit of the maximum speed. If you are going higher maximum speed, so suddenly the motor may damage the equipment. So mainly in the commutation process. So here armature control method and rheostat control method talk about. So armature control method, so here n is directly proportional to eb, that is v minus ia ra, and that's the EB. So variation of voltage across the armature, where is the back EMF. So if you control the voltage, okay, so if you control the voltage of the supply, so it will control the back EMF. That's why variation of voltage across the armature varies, the back EMF varies. So the speed also we can control. Here, higher the voltage drop, okay, higher the voltage drop in the armature winding is the lesser the back EMF. So higher voltage drop in the armature winding means the lesser back EMF. So and hence speed can be obtained. In the armature control method, we are getting the below rated. Okay, that's why we are getting the armature control method below rated. So in the field control method, we are getting the speed in the above rated. So that is a reason. There is voltage drop will take place. Okay, so these will affect on the load. Okay, so these method will be affect the load. So here the construction will talk about. Here the so we are placing the armature. Okay, so placing the restart with, so we are placing the variable restart with the armature. Okay, in series we are placing the, so the field winding equals to the constant flux. So and the current flowing through the armature, that will be controlled. Okay, and also voltage drop we can observe. If lower the current, voltage drop is higher. So that's why we are reducing that. Okay, the voltage drop by means of the kinetic in series with the resistor. Okay, so a control resistor is connected in series to the armature. Okay, so here n is directly proportional to the IARA. So the IARA drop we can run. So because of RC, the voltage drop increases, so back EMF reduces. So here what we are doing, we are adding the resistance causes the voltage drop. That's why the back EMF reduces and the speed also reduces. So higher speed obtained is corresponding to RC is equal to 0. Okay, so advantages we can get the below rated speeds. Disadvantages, large amount of power is wasted in control wastage, because in case of this field control method we are getting the only less amount of current to vary the resistance. But in case of armature control method, the power is very wasted because we are controlling the voltage drop. Okay, that's made the higher power loss. So the speed is vary widely with load. Okay, this is another disadvantage. And if it is load is varies, okay, when the speed varies, so that is also affect the output and efficiency also reduces. So this method gives the poor speed regulation compared to the field control method. So these are the methods, that is the field control methods. So here we conclude that. So here we have discussed the two topics, that is armature control method and field control method. So armature control method we are getting for the below rated speed, and field control method is the above rated speed. Okay, so this is about the how we can control the speed of the DC shunt motor. Okay, thank you.